Okay, so let's just compute. Well, what do you want to find out? You want to find out the value of c. Well, you know that your integral is basically 1 and the range is this, right? So you have c outside and then double integral 0 to 1, 0 to 2. Well, for the 0 to 1, let me see if I take that to be in positive. Yeah, x is 0 to 1. So this is for x and this is for y. So x plus 2y, right? And then dy dx. How would you solve it? The first integral is just with respect to y. So you have x, y plus 2y squared over 2 evaluated at 0 to 2, and you have c here, and then 0 to 1 here, and dx, right? Well, just substitute 2. For the zeros, you're going to get 0 anyway. So for the 2, you get 2x, and then 2 is going to get cancelled. That's just 4, right? Because 2's get cancelled here and here. So you get y squared, and this is now you want to evaluate, right? And this is equal to what? I mean, I don't want to be doing these things. And then c. So that's just 2's get cancelled, 1. C is basically 1 plus 4, right? So 5c. And on the left hand side, you had 1. So c is equals to 1 by 5.
1 by 5.
Clear?
Yes.
Okay, good. So c is my 1 by 5. Let this be a joint CDF. It's donated by a capital F, which tells you that it's a CDF, right? Compute this and compute this. I can already see what this is going to be equal to just from the definition of a CDF. What is this equal to? Even without computing it, you can tell me. That's just 1, right?
Yes. 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 It's 1.
Yeah, okay. Let's just now calculate f of, I'm going to use the dummy variables. So 1 by 5 inside, and then 0, 0 to a and b. And then I have x plus 2y, right? dy dx. What is this equal to? X, y plus y squared, again 0 to b, 0 to a 1 by 5, and dx, right? So that's just bx plus b squared. And then I calculate for the a, I get x 0 to a 1 by 5, and then dx, right? And then what do I get? B x squared by 2 plus b squared times x, and then 0 to a, and 1 by 5 here. So what is this equal to? 1 by 5, x squared is a, so that's just b x squared by b a squared by 2 plus b squared a, right? This is my f of ab. If I want to now talk about these, so I just substitute x in terms of a and b for y. So what do I get? F of xy is this equals to 1 by 5. B is what? So AB, right? I took A for my X. So A for my X, that would be Y X squared over 2 plus Y squared X, right? Is that point clear?
Yes, sir.
Okay, and then when I substitute 1 and 2, so for X I substitute 1, so what do I get? And for Y I substitute 2. So 2 over 2 is just 1, right? And from here, what do I get? Well, this is 2 squared, so 4. 4 times 1 is just this, so 5 over 5, and I get, right? So this is being multiplied by this, right? So I get 1, which is what you predicted, right? It's a CDF, so at the extreme values, which are defined by your range, you're going to get the probability equals 1, right? It's cumulative. It accumulates. Fine?
Yes.
Okay, now the marginal densities. So as I said earlier, this is just going to be the PDF small f, right? Equals x or a, whatever you want to call that. So getting the individual probability density function from the joint probability density. How would you get that? You just integrate it with respect to the other variable. So you add all of those up, right? And then you're gonna be just left with your the probability density function for just one variable. So you integrate it now if you want to compute the probability density function of x, right? So you just integrate the whole thing, which is this xy with respect to y, right? And what are the limits of y? Well, that's 0 to 2, right? These. So that would just be then 1 by 5 x plus 2y, 0 to 2 dy. Well, this is what, I mean, these integrals are so similar that y and then y squared and then evaluated at 0 to 2, 1 by 5. So what is this? 1 by 5, 2. So I'm integrating with respect to y, right? So x times 2 plus 4. So 2x plus 4 over 5, right? Probability of x equals x is equal to, this is the probability density function, right? This is not the CDF. Is that point clear? Let me verify I've gotten these correctly. Yeah. I don't know if I've gotten the answer, like the correct answer, but I mean, the idea is the same. I don't have the answer here right now. So yeah. Likewise
Sir,
for
I
the
got
Y
the same
case.
answer.
Okay, good. So that means probably we're right. The other one would just be integrating over x. So that would be f of y equals y, right? This thing. And what would this be equal to? The joint thing, 1 by 5, 0 to 1, and then x plus 2y integrating with respect to x, right? So you're accumulating all the probabilities, right, of x to get the independent probability distribution of y, right? Do you understand this? That is it. It was exactly what was going on here as well. Here when I wrote all of those, right? Like the marginals.
Yeah.
Okay.
Okay.
Because I was
Yes.
adding all of these up, right? To get the probability of x, like the probability mass function of x, right? I added the column. And what was the column? Like whatever those were, 0, 0, and some 1 by 5, right? So these were getting added up and you got here 1 by 5, right? Do you understand that? So I was adding these, all of these, just like I'm doing
Yeah.
here. Just the difference is that this was a discrete case and here it's the other case, which is
तो सर
continuous. Yeah.
ये जो हमने अभी निकाली हैं सिंगुलर probability density functions for x and y,
Yes.
these are the marginal
Yes.
densities, right?
Yes.
यही marginal densities हैं. Okay.
नो, वहां पे तो आपने पीएमएफ निकाली है ना, इंडिविजुअल, लाइक प्रोबेबिलिटी मास फंक्शंस ऑफ द लाइक सेपरेट रैंडम वेरिएबल्स, बट यहाँ पे आपने प्रोबेबिलिटी डेंसिटी फंक्शंस निकाले हैं बिकॉज ये
Yeah,
कंटिन्यूस
yeah,
है,
I was
राइट?
talking about part C. I was talking about this question.
ओके, ओके, या. सो नाउ व्हाट वुड बी योर ई ऑफ एक्स? जस्ट 1 by 5 x times what was the probability density function, like that the one we computed? So this thing, what was that?
It was 1 by 5, 2x plus 4.
So 1 by 5, 2x plus 4. 2x plus 4, right? And when should I now dx and then 0 to 1, right? In exactly the same way, what would you do for the other one? For the e of y, well, you have just the same thing, 0 to 2, and then y, and the sorry, small y of this, small f of this thing over here. Is that point clear? Or do I need to do this?
Yes, it's clear.
Okay, okay. Now the last thing that we're this thing over here. How should I go about it? I want you guys to tell me. It has both, right? And there's a theorem in your lecture 10 as well that mentions this as well, right? That if you have a function of your random variable, how does that translate to the expectation? What would this be equal to? I mean, simple, this thing and the joint, right? Probability of this, sorry, joint probability density function. Another way could also be, by the way, so x, sorry, x and y, capitals. X and then y, right? And then you have the dy dx. And then 0 to 1 was for that, so 0 to 2 and 0 to 1. And then 1 by 5 here, and you substitute this with this over here, right? Which is just x plus 2y. And this is it. You're going to calculate this. Can anyone calculate this? Or do you want me to calculate it? We've done these integrals, right? We've done these.
Sir,
Yeah,
can you just explain once again how you reached this expression?
yes. So what I'm saying is,
Ano sa link ko ya? Yani link pasang ako.
uh, hello. Yeah. So what you're doing is you have, okay, hold on. The idea is this. The expectation of your random variable is what? Your x times your probability of this, right? X equals small x dx. Is that point clear till here? Like, do you understand
Yes.
this? Okay, good. So exactly in a similar fashion, if you have a function of your random variable, you substitute instead of x just that function, and then the probability density function of this, right? I should write, technically speaking, an f here, not the, this is bad. Should write f and f, which is this is a PDF, right? This is not the probability, right? This is the definition of your expectation, right? From minus infinity to plus infinity, or whatever your region is defined at. Yeah. Is that point clear? Till here, are you with me?
Yeah.
Okay. So now if I extend this definition, I mean, you can also think about this, that I can also think, first of all, expectation is a linear operator. So what this is this. I can also like do this thing over here as well. But another way could be that I defined this to be my z, right? If I define it to be my z, another random variable, right? Then I rewrite the whole thing in terms of z. And then when I substitute, obviously, I'll have to make sure that now I have two integrals rather than one. Okay. So if I extend this similar definition to an expectation of, let's say, two random variables, right? Let's say x plus y. Now I need to have, this would be like the PDF of, oops, sorry, let me see if I can, uh, yeah. So this would just be x plus y, right? And then the joint probability density function. I should write f of x and then y, dx dy. So I've just basically, whatever I have here, I just translate it inside my integral. And if I have like two random variables, then I have to use the joint PDF. I can't use a single PDF, right? Because then I have to integrate it at all the values and then add them up. Is that point clear? Hello? 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 Yeah, is that point clear? There's someone in the chat. Oh, all right. Okay. So would you be able, I can't hear you again. Okay. Do you guys want me to solve the integral? Yes or no? Please just let me know and then I can end. If you want me to solve it, I can. Else, I mean, we've done the similar integrals, but I'm guessing we can solve it on your own. All right. If anyone else wants me to solve it, I can do that. You guys, someone needs to mute their mic.
Hello,
Hello? Hello? Please write it in the chat or something. All right, guys. I'll upload this and I am audible, right? Okay, good. All right then. See you guys. Bye bye.